Here are a few more examples of factoring our quadratics. So the first one is just going to be factoring, and then the second one will factor and solve. So the first thing you should look for when you're factoring is to see if there's any common factors. And this one's so close because we've got a 6 there as our leading coefficient and a 12 as our constant term, but then we have a 17 in the middle. So we don't have a common factor, but we were sure close to having one. But then I go right in and I like to try guess and check. And again, with guess and check, what we're doing is figuring out the ways to multiply to get our leading term and the ways to multiply that we can get our constant term. So this leading term, we could have had a 1 and a 6 or a 2 and a 3. And then our constant term here on the end, we could add a 1 and a 12, a 2 and a 6, or a 3 and a 4. So I'm just going to make a guess. Oh, wait, there's one more thing we can know. We can know what the signs of our factors are. So that positive there on our 12 tells us that our signs are the same. And then the negative on our middle term tells us that they're both negative. So when we're setting up our factors, we know that we're going to have an x and an x. That gave us our x squared there. And then our two signs are both going to be minus. So now I'm just going to make my best guess. I'm going to put numbers in and see what happens. And, hopefully that this can help me, if I don't get the numbers right, make a decision about maybe how to change them. So I picked 2 and 3 and 2 and 6. And again, I don't have to FOIL this whole thing out to check. I know for sure that my 2x times my 2x is going to give me that 6x squared. And I know for sure that my 6 times my 2, that's going to give me 12. I picked those numbers because they give me 6x and they give me 12. What I really, really need to check is that outer term from FOIL and that inner term of FOIL. So what do I get from doing the 2x times negative 2, and what do I get from doing that negative 6 times 3x? So I get negative 4x plus negative 18x. So, ooh, that's too big. That is negative 22x, and we want negative 17. So I'm feeling like that 6 where it is being multiplied by that 3, that's too big. So maybe we'll try just flip-flopping where that 6 is and see what happens. So again, all we have to check is that outer part and inner part of FOIL, making sure that those are going to give us the correct middle term. So we get 2x times negative 6 plus negative 2 times 3x. So we get negative 12x plus negative 6x. Oh, this is really close, negative 18, but we wanted negative 17. So again, that's not right. And we've now done all of the choices with 2 and 6 as our ways to make 12. So maybe we'll pick a different way to make 12 because we're getting really close here. So maybe we'll use 3 and 4 instead. All right, so again, I'm just going to plug those in, and I'm just making a guess at where to put the 3 and the 4. That may be right to put the 3 with the 2x and the 4 with the 3x, but we might have to switch them. We'll see. Because again, what we're needing to check is what happens from the outer part and the inner part of FOIL. So we get 2x times negative 4 plus negative 3 times 3x. So we get negative 8x plus negative 9x. Aha! That did it. That gave us exactly what we needed, and there's our factored form. So guess and check will work. Sometimes we have to run through a few options. It's nice to keep it sort of nice and neat so you can see what your examples are. I don't think it's a good idea to erase things that didn't work. Keep those options there so you don't end up repeating yourself when you're switching numbers around. So I found it on the third try, which is pretty good. We also have the option to do that factoring by grouping. So I can show you that as well. So grouping is where we take our quadratic. Sorry, I'm writing down here, so I'm vamping just a little bit, but we take that leading coefficient and our 12 and we multiply them. So 6 times 12, and that is going to give us 72. And then we're going to list our ways to make 72, and we're going to figure out which ones of those add up to give us 17. and we're going to have them being both negative. So we can have -1 and -72, -2 and -36, -3 and -27. And I kind of also add these as I go to see what I get, because we're trying to figure out which ones would add to be 17. So this is -73. This is -38. Sorry if you can hear my cats going crazy in the background. This is -27. So we're getting there. We're going to keep going. I think 4 is also a factor. Yep, -4 and -18. So that's still not going to add to give us 17. 6. How about -6 and -12? Oh, we're really close right here. That's -18. Let's see, what else is a factor with 72? Aha, -8 and -9. That gives us -17. And again, kind of going back over here to where we were checking, look at our two numbers that we got there that added up to give us that 17. Oops, and I have a little typo here, don't I? That's a 17. We had -8 and -9, and that's exactly what we used here in grouping. So this is our winner, and this is how we're going to split up that middle term. We're going to split it up with a -8 and a -9. It absolutely doesn't matter which one of those you write first. You could write -9x and -8x. That's totally fine. And then we're going to group the first two terms together and the last two terms together. And the way that I do this, which is sometimes a little different than other people do, is that I take that negative sign and I keep it with my 9. I keep it with that coefficient so that that sign in between my two groups is positive. All right, so now I look at just the two groups. I look at just that 6x squared minus 8x on its own and say, what's common to that? I kind of just totally ignore the other two factors. And this has a 2x in common. So we're going to factor that out. So we get 2x, and then we're left with 3x minus 4. And then we look at our second group here, again, ignoring what's underlined in blue and say, okay, what's common to both of these factors? And when we've got that negative sitting there in front of that first coefficient there, I'm going to pull out a negative, and it's going to be -3 is what's common to both. So we've got -3 that we're going to factor out of that. We're going to be left with 3x and -4, because again, we want to be able to distribute that -3 back through and get right back where we started. And now again, we take this as two terms that have that common factor of that 3x minus 4. So we're going to factor out 3x minus 4, and here we're left with 2x. Here we're left with plus a -3, and we have it factored. So we can write it that way, or you could write it also as 2x minus 3. They're the same. Both are correct. Either's fine. And so then we got it factored. Awesome. Let's take a look at our other example that we've got down here. And again, it also, while I'm looking at these and scrolling here, it doesn't matter the order that you write the two factors. Either way, it's multiplication, so it doesn't matter. All right, let's take a look at another one. All right, so here's one where we have to do some solving as well as some factoring. So I'll tell you that this one does factor. And whether we're factoring something like this or, oops, I don't know how that turned into an 8. It still should be a 4. There we go, 4x, 4x. So we get minus 17x equals 6. So whether we're doing something where we're factoring or using the quadratic formula, whatever method we're choosing, we want to get everything all together on one side. So we did that. We got everything all together on one side. And if we're factoring this with guess and check, because again, that's generally where I start, guess and check. We're looking for, what are the ways that we can multiply to get 10, and what are the ways that we can multiply to get 6. So the ways to multiply and get 10 are 1 and 10, or 2 and 5. The ways to multiply to get 6 are 1 and 6, and 2 and 3. And then when I'm setting up my factors, I know I'm going to have an x there, and an x there, and I'm leaving a little space because I know I'm going to have coefficients. And then I look at our signs. Aha, that one being negative, our constant term being negative, tells us that our signs are different and that what ends up being, and we'll put this in quotes, bigger, needs to be negative. So we're going to have one negative and one positive. And now, again, I'm making my best guess. I'm going to put stuff in here and just take a guess. So I picked 2 and 5 and 2 and 3, and I'm going to see if this works. So again, we do not have to check all of factor or all of foiling. We just need to check the outer term and the inner term. Because again, our 2x times our 5x, that will give us 10x squared. Our negative 3 times our positive 2, that will give us negative 6. So let's see what we get here. You get 2x times 2 minus 3 times 5x. So we get 4x minus 15x. Sorry if you heard that ding when I get text messages. I get dinged when I'm making videos, so I apologize for that. So we got negative 11x. So that's not quite big enough. And sometimes as you get a little better at these, you'll start to see, okay, if I flip flop where I have, sorry again for the second ding there, if you heard that, if I flip flop these and put the 5 there and oops, that's not where we would flip flop the 5. We'd flip the 2 and the 3. That's not really going to make anything any bigger because we're going to get 2 times 5, which is going to give us 10 instead of 15. So I oftentimes, without even foiling, will say, I don't think this is right, so I'm not going to try that. And maybe because I need a bigger number, I might need to look at that 1 and 6 or that 1 and 10. So again, I'm going to take a guess and maybe I'll leave my 2 and 5 and maybe I'll try 1 and 6 and see what happens. So we'll try it out here. See what's going on and try those outer terms. So we get 2x times 1 and then plus negative 6 times 5x. So we get 2x minus, ooh, that's way too big. That's negative 28. All right, so that was way too big. Well, if I move the 6 over, if I flop kind of where the 6 and the 1 are, that's not really going to help because that's going to give me 12 from multiplying by that 2x, right? That's going to give me 12, that's going to give me negative 5. I think that's not going to be big enough. So, I don't like that one either. And so maybe we'll try 10x. And I don't think I want to use the 1 and 6. Maybe we'll go back to the 2 and the 3 and see what happens. So maybe we'll put the 2 there. We'll go x minus 3. And we'll try this out. We'll see. And this is about the point where I might start getting frustrated and going, could I try something else? Oops, that gives me negative 28. Well, what happens if I switch the 2 and 3? Maybe that would work. See what happens here with that outer and inner part of foil. So I get positive 20x minus 3x. Oh. I got positive 17. And I went, see, now I almost forgot what we were working towards, right? We want negative 17. So that means we're really close because we got the exact opposite of what we wanted. So that means all that we have to do is switch where our positive and negative is. So we're going to leave the 3 where it is, we're going to leave the 2 where it is, but we're going to flip-flop what's positive and what's negative. Because now when we check that, we're going to get negative 20x plus 3x, and that's going to give us negative 17x. So, all right, we found it finally. It is 10x plus 3 and x minus 2. So we've got it there. And our 2 solutions, because we need to remember that if we're solving this, we've got to set each of those equal to 0. And we get x equals negative 3/10, or we get x is equal to 2. So if we do, especially if we're working on one where we're solving, and we start to get something like this where we're working, and we're not getting to where we need to be, and we're getting frustrated, something that we can do is go to the quadratic formula. That's okay, especially if it's a time where we're getting frustrated, because I don't want you to get frustrated with these. So taking a look at the quadratic formula, I'm just going to try to make it a little bit nicer for our work here. We do need to make sure that we're in this standard format where we've got our ax squared minus bx plus, or ax squared, let me write it out, plus bx plus c equals 0. There we go. We need to have it in that format. And I always think it's wise to write down what is your A, what's your B, and what's your C. And those positives and negatives go with B and C, as well as A. I guess it goes with all of them. So I always write that down, and then I always write down what the quadratic formula is. And I always write it down because that, number one, helps me make sure that I plug all of my numbers in the right place. But it also helps me when I'm memorizing things. If I write it down over and over again, I just have it memorized without even trying. So let's see, the opposite of b is going to be the opposite of 17, and then we're going to get negative 17 squared minus 4 times a times negative 6, and then all over 2 times 10. All right, so I hadn't done all of this in advance, so I apologize for grabbing my calculator here to do some of this work. So squaring 17, we should always get a positive number for b squared, so make sure you get parentheses around that. You should get 289. And then I like to do negative 4 times 10 times negative 6. That gave me positive 240, right, over 20. Okay, so we've got 17 plus or minus the square root, so our 289 plus 240 is 529. Now, something I like to check on this is, did I happen to get a perfect square? So I'll take the square root of that 529, and you actually get 23. Because when you get a perfect square like this, that means we can actually figure out exactly what these two numbers are as either fractions or whole numbers. So we've got 17 plus 23 over 20 and 17 minus 23. Whoa, that 3 got a little crazy. Minus 23 over 20. So doing our first one, 17 plus 23 gives us 40 over 20 gives us 2. Oh, there's our first solution. And then 17 minus 23, that gives us negative 6 over 20. Well, that is negative 2 times 3 and 2 times 10. So that negative on the top doesn't cancel with the top and the bottom, but the 2's do. And we get negative 3/10, which is our other solution. So even if you can factor, you can always check with the quadratic formula, or like I said, if you're getting frustrated, go ahead and grab the quadratic formula, because that can also tell you what your two factors are, because you can also work backwards from here. But, remember, we have options, just that either if you're using the quadratic formula or if you're factoring, make sure that you get into this standard form first, where you've got everything all on one side and your other side equal to 0.